Okay, this is the video for Module 4, and you should have what Emily French put together, the PDF for Module 4, which I'll open up here for a second and show you. She gives you a very nice step-by-step of how to download and incorporate the data from Opportunity Atlas into a GIS program. She does it in a slightly different way than I'm going to show you right now. The way she's showing you is how to kind of download information for all the tracks in the entire United States and then actually go find a shapefile for your state. So you're doing kind of a much larger, entire statewide join for depending on where you are. What I want to show you is using what's called a GeoJSON inside of Opportunity Atlas so that you can kind of just navigate to your extent in Opportunity Atlas, hit download twice, and then do a join and a save as, and you'll get the same thing. So you can follow Emily French's example, and that should work out just fine. It is nice, it's step by step, but what I'm going to show you in this video is a little bit more of a kind of a faster way to, I think, get at the same thing. Maybe not faster, but just a different way. So the first thing I'm going to do is I'm going to open up my old file. I'm going to open up my midterm Chester. This was from a few weeks ago when I was kind of showing you how to arrive at that percent African American or Black against the Hulk district. So this is kind of that final map I ended up with there. And the goal of this whole lab is to be able to bring in other data, in our case is incarceration rates, and show them on the same map, maybe a different map, but the same GIS platform so that we can look at it. So what I want to do is I want to go open up Opportunity Atlas and begin exploring. And there's a lot of stuff here. In our class website, I've given you a couple of videos, and one of them is from a former student who made a video about how to use Opportunity Atlas. But even Opportunity Atlas itself has kind of something like how to get started. And I know that they also have some guides and some tutorials, so you can explore those as well. But what I want to do right now is we're looking at incarceration rates. And so what I'm going to do is, first thing I'm going to do is zoom into my area. And I'm looking at Chester for the purposes of our lab. So I'm going to zoom in near Philadelphia, and there's Chester. And I'll let it load, and I'm seeing tracts, and that's about what I want. I want the tract level. So that's pretty good. I could zoom in a little bit more, but I think I'm going to just leave it just about like that. And so what I'm doing right now is I'm framing up how much data I want to download. And my rule of thumb for this is kind of always take more than you need. You don't want to take everything, but if I know my map is going to be maybe 1/3 or about half of the extent, then I give myself wiggle room around the edge in case I change my mind about how I want to frame the map. So in this case, I might even think about getting more Philadelphia if I want to make another map someday up in that area with the same file. So I'm going to just do that. That's not too bad. That looks pretty good. And the key with this, as Emily says in her module, is that we want to do all. We're going to do all for all of these, and we're going to pick incarceration rate. So pick incarceration rate, and this is showing us based on no filters for the entire population what the different percentages are of the expected outcomes. So incarceration rate, all. For your final papers, you'll pick a different metric that you think is interesting. Remember, we talked about outcomes versus neighborhood characteristics. So this is projected outcomes based on the environment in which you were raised. Kind of late 80s, early 90s to 2010, 2015, and then neighborhood characteristics. This is kind of like what the environment is supposed to be like now, or close to now. It looks like 2012, 2016, 2010. And we, in class, we talked a little bit about the differences between projected outcome and current characteristics. So we're picking incarceration rate because that's that's very applicable to the readings you've been doing. Oh, I just zoomed out, but that's okay. I can keep it like that. And now it's quite easy, actually. What I want to do is I just want to download the data, right? I don't want to do anything more complicated. I'm using this as a tool for data extraction, not for visualization, though we do see that it lets us play with the visualization if we want. We can paint the data different colors. But for now, so long as we have our data we've chosen, we go all, we're going to go over to download the data. So we click that, and we get this window. And I'm going to say, let's get the tracts. That's what we want to get. And I know because I've done this a lot that's what I'm seeing on the screen. But if you're not sure, pick tracts. That's the highest level of detail that you can get. And we don't want any particular subgroup. We want all. So that's fine. And then this is the part you need to pay most attention to. When I hit download here, I'm actually telling it to download the table. It's called a CSV file. And the CSV file is what records the number that goes into each of these boxes, right? In the world where GIS is kind of egg, carton, and egg, the geographies are these egg cartons. These are the shapes, the boxes that hold the numbers. And then the eggs are the numbers that go in the boxes. So the eggs in this case are incarceration rates. And when I say download and I click it, it's going to come up here for a second. Maybe it is downloading the entire. I probably should have just said just what's on the screen. I know I kind of, maybe I lied there. Okay, so now it's downloaded, and I think we'll have to look at it, but I bet you tracks means it's going to do the whole country, and I probably could have clicked just what's on the screen, and because I see that they're tracks, I would know that it's much less. So if I go just what's on the screen and I do it again, download, then it's much faster. Yeah, 46 kilobytes. So either way, this is getting me the whole country. This is getting me just what I see. But now what I want to do is, instead of just downloading the data, I want to download the shapes. What are the buckets that these go into? And you see all these tracks. I want to say download on-screen shapes, and that's going to get me a shapefile, or not a shapefile, something called the GeoJSON, which is another vector file format of just what I see here. So I say download on-screen shapes, and there's my GeoJSON. So I'm going to drag these three into my working folder here. And you know what? I'll create a subfolder just so I don't get too confused, called Op Atlas. And I'm going to put my data in here for my download, my GeoJSON. And let's put in the big tracts and the little tracts. And so now what I want to do is I want to load them in to my GIS program and just see what they look like. So to do that, I'm going to go back up here, go to my project home browser here, go to Op Atlas. And this GeoJSON is just it's a vector file format. So I can just click and drag that into here, and it will pop in, and I'm going to see, oh, wow, okay, tracks are a lot more generalized, right? So my previous map was based on blocks, which are much finer detail. And then this block group is in between, and what I'm looking at right now are called tracts. And so these tracts are going to be the buckets that we put our numbers into. Some of these ones that are empty are probably no population or low population. But so that's good. So I know I've got the boundaries that I want. The first thing I do before I do anything else is I'm going to convert this file. A GeoJSON is fine, but I want to save it as a shapefile because shapefiles kind of work with tables a little bit better. So I'm going to say export and save features as, and I want to call it something intentional as well. And it doesn't really matter what I'm just changing, this is the projection. You know what, you could just leave it as the default, it would be fine. I'm just changing it to this project one, which is also not great, but it's based on the web map that I have on the bottom there. Doesn't really matter, you can leave that. But so now I need to go back to my midterm folder of Atlas, and I'm going to call this I could just call it tracts, because that's the only thing I have going on right now. So I'm going to say tracts, and I say OK. And now I've got a shapefile that looks identical. And it might seem like, well, why do you even care? But just trust me, you do. You want to make sure it's a shapefile is the easiest one to work with. So I remove the shown geography. I've got my shapefile. And if I open up the attribute table, you'll notice all I have is an ID. There's no information associated with these shapes. They're just shapes. So the next thing I want to do is I want to give those shapes numbers to populate inside so that we can paint them different colors. So I'm pretty sure that this shown tract is something I could just dump in here. And I bet you if I open this, there we go. We've got those numbers, those tract numbers, and now we have a name and incarceration rate that we can join right to here. So a join is when you take two pieces of information, usually two tables. So here's one table right here. And this table is, there are no geographies associated with this table. They're just a list with tract names and then name and then incarceration rate. And they're all just listed there. And here is another table. So these two tables, this table is just an ID that locates every single tract. And of course, you might say, well, why do they have it this way? Why don't they just have all the data in all the tables all the time? And the reason is that there are, as you remember in Opportunity Atlas, many, many, many dozens, if not hundreds of things that you could download for data. And it would be inefficient and it probably wouldn't work actually if you wanted to filter these and that kind of thing to have all of the data attached to every single tract. So the point of a join is so that you can download the data you want and then you can link it up to the geography that you want to show. And the join helps us do that. It connects these two pieces together based on these ID2 and tract. So to do the join, what we got to do is we have to we can right click this and go to properties, or we can double click it. And we're going from the file that is the geographies, the shapes, the egg carton, right? And I'll talk about that in a second, the difference between geography, geometry, and record and attribute in a second. But to start with, let's go and we're going to open up layer properties. We're going to go to joins. And we say plus. We want to add a join. And the join we're going to add to this tracks file is the shown tract. It's this table. And it's kind of, the computer's done a good job. It's already, it can kind of tell. It's like, oh, okay, tract ID2. These are the ones that you want to try to join together. So now I'm going to say join fields, and I want to join these two extra ones. And then I am going to create a prefix, and this is I'm going to rename those fields so that it tells me what it came from. So I usually put like a J in front of my renames just so I know that it came from a joined table, and you'll see what I mean in a second. So pick the table you want to join, pick the key field, the one that's the same between the two, which is in our case tract and ID2. These are both the same, so the records in one relate to the records in another. And then the join field, name and incarceration rate. These are the ones that we want to bring over. We could bring over tract, but it would be kind of redundant to have tract to tract. We'd have multiple sets. So say OK, say OK. And now if I go and open up my attribute table, what do I see? But I see, aha, here's my old ID. And when I opened my egg cartons for the first time, all I had was ID. But now I've put an egg in each egg carton slot. And I've got ID, joined name, and joined incarceration rate. So that's pretty good. What I want to do now, though, is I want to save this again. And I know it's kind of laborious. But when you do a join, the join is kind of related to the table, but it's not stored there. So when we save again, we're going to lock this file in so that these geographies always have the data that are associated with them instead of just being kind of joined in virtual memory. So what we got to do is we just got to say export, and then we'll just kind of do the same thing. And instead of tracks, I'm just going to say tracts joined. I say OK, and it's the same exact file again. I'm going to remove the old one, except now they're just in there. And if I remove this layer, I'll show you what I mean here. I'm going to remove that layer. I go back here, hit refresh. Now, if I had removed them and now I bring in tracks again and I bring in tracks joined, the tracks file, poof, it does not have the data even though I joined it, because it was kind of it was storing it kind of in a virtual way. Like it was, the computer program knew it, but as soon as I took the layer out, it doesn't remember. When I saved as, I created a new one that kept the data with it. So that's kind of the importance of saving after you join. Okay, so now it seems like I'm almost ready to make some choropleth maps, right? I'm ready to just throw some color on the page here. Let's see what happens when I try to do that. I'm going to remove this table. I don't need it anymore. And now I open my properties. I'm going to go to symbology, and I want to symbolize incarceration rate. So I'm like, yay, I'm so excited to do some cartography. And when I symbolize numbers in Q, I go to graduated, and oh no, what's going on? And I kind of knew this was going to happen, but it's a good teaching moment. The only number that's showing up is ID, but that can't be, right? Because I have, I know my incarceration rate is in there. So let's open up the table and see what's going on. Open up the table, and what is going on here? I see a number right here, and I see a number right here. Well, the difference of what's going on here is called, it's data type. And so data type means what is a number being stored as, or what is any value being stored as, right? It's pretty easy to look at this and know that the values in this column are being stored as text, right? The values in this column are being stored as a number. And the quick and easy way to tell is when things are justified to the right, like in Excel or other tabular programs, it's a number usually. And when it's justified to the left, like it is here, those are usually text. So when I look at this number column, it looks like a number, but it's being justified to the left. And that's just an artifact of the CSV file format. It's not something you would have known necessarily, but you encounter it all the time, so it's good to learn. And what this means is that even though this is a number, the data itself are not being stored as a number. The computer is reading this as 0.1171, not the decimal, 0.1171. So if I want the computer to read this as a decimal, I have to convert it to a number format, or a number data type, called a real. In computer language, text are called strings, and and numbers can be called integer or real, and real numbers have a lot of different, both sets. There's long integer, short integer. There's a whole bunch of different data formats. Don't need to worry about that right now. But so what we want to do is convert this to a real number. So to do that, I'm going to open up my field calculator. Well, okay, just pause for 1 second. The other thing important about this is that it is occasionally important to store numbers as text, right? So you might think, well, that's kind of annoying. Why would you do that? But in the case of zip codes or other numbers being used as names, it's kind of important to use it as a category or as a name instead of as a quantity, because, for instance, the zip code that I live in, 04937, the 0 that is in front of the 4 is really important. 04937 means Maine in South Bristol. If it was stored as a number, you would lose that leading 4, and the computer would automatically think instead of 04937, it's 4,937, which is not a quantity of anything. It's just a name. So that's why sometimes we store numbers as text instead of as number. Anyway, going back, I'm going to go and use my field calculator. We're going to create a new field, and I'm going to call this incarceration rate. And the first thing I'm going to do, I'm going to be storing this as a real number, a decimal number. And I'm going to make it as wide as I can. So I usually do like 20, even though it doesn't need to be that big. And then it looks like precision is the number of decimal places. I want to maintain what it came in with. It has 4. So I'm going to say precision of 4 because there's 4 decimal places to the right. And now I need to go to conversion and say to real, like this, to real. And then it gives me kind of just like in Excel, a bracket. I go to fields and values. I'm going to enter incarceration rate. You see these letters next to it here. That's telling me that this is being stored right now as a string, as text. So I do that, and I close the parentheses, and I'll see that, aha, it's going to try to have an output here, preview for my output. So I just say OK, and you'll see what's going to happen. I say OK, and poof. And it looks like the exact same thing, but one is justified to the left, a string, one is justified to the right, a real number. But this is still not quite what I want to show. Just like we talked about in class, ratios are funny, right? They're relationships between large sets of numbers. In their most raw format, it's always between kind of 0 and 1, 0 being nothing and 1 being everything, kind of complete. And a ratio can be anything, any decimal between 0 and 1. We're very commonly used to using percentages. But if we use a percentage with its incarceration rate, most of our percentages would be below 1%, and sometimes even much lower than 1%. So for population metrics, it's very, very common, instead of percent, which means per 100, to use per 1,000 or per 10,000, per 100,000. In our case, our numbers are being reported to the 10,000th place, and I think that's it seems to me to be the significant figure here. So what we're going to do is multiply this ratio by 10,000 to get our incarceration rate per 10,000. So to do that, I'm going to open my field calculator again, and I'm going to call this one inc per 10K, incarceration rate per 10,000. And I want to make it a real, I could make it an integer if I want, but I'm going to keep it real. And in this case, I don't need any decimal because I know there's not going to be a decimal, but I'll give it 2 places just for the heck of it. It doesn't really matter. Incarceration rate, that's the new one that we calculated, and you can see it's a number, not text, times 10, 1, 2, 3. So this is going to give me a incarceration rate per 10,000. So I say OK. And now I've got a nice number to use there. So that's great. So now I can hit save and unedit, or toggle my editing mode off. And with all these files, you can't just do this stuff. You have to edit. You have to go into edit mode. So anyway, so now I should be able to make some maps. So what I want to do is I'm going to shut off my other data layers just so I can get just the base map. And now let's try to do some symbology. I've got my tracks here, so I'm going to open these up. And now if I go to graduated and my symbology, I should be able to find, incarceration rate per 10,000. And I could just, as we've done this before, hit classify. And those are the default values, which don't seem, they seem overgeneralized. So just like I did before, add a few more classes. Maybe I'll look at the histogram. Load. And it looks roughly geometric. So maybe I'm going to do 10 classes, and I'm going to make it, maybe I'll use this color scheme, hit apply. Okay, now we're starting to see a little bit more variation. It's looking a little bit more sensible, like something I could actually write about. But let's just say, like I said before, we could do equal count or we could do equal interval. But remember, they come up equal interval. It kind of deadens it a little bit. You look at the histogram. These are all going into one bucket, and then these are kind of getting spread out. Equal interval and quantile, equal count are kind of the two base ones that you would normally look at first. Natural breaks is just an algorithm that kind of like looks for places that are good breaks. It kind of roughly looks like it's doing a geometric thing here. That's actually it's kind of nice. But I think for my purposes, I want to do something closer to quantile, because the difference of the variation, I want to really stretch out to show that there are some places it's dramatically more In some places, it's dramatically less. And then what I tend to do with these, I don't know if you can remember, but I do a manual classification because, all of our maps are to communicate with people, and people think best in round numbers. So I'm just doing kind of a geometric 0 to 10, 10 to 25, 25 to 50, 50 to 100, let's say, 100 to 250. Oops, I'm getting mixed up here. 250 to, let's say, 500, and 500 to 750. I did this for the other one just about the same. I kind of did a geometric, and then when I got to a certain level, I just did kind of equal, what do you call it? Not equal. See, I'm going to go back now. I hit the max. So I'm going to do 5, 10. I do, 10, and then this is 5. Oopsie. Sorry. This one should be 5 to 10. 10 to 25. So my logic here is let's do roughly geometric, which has more of a quantile feel, or a equal count. But then once we reach that threshold where things are kind of crazy, right? So around 500, it starts to spread out the tail of that distribution. And then I'm just going to do 250 as my interval there, because I think it's going to look good. You'll see what I mean when I look at the histogram. 1,000. And anything over 1,000 is getting that bright yellow. So I'm going to hit apply. You'll see what I mean here. Yeah, it's pretty good. And then I go to my histogram and I can kind of see, like, oh yeah, I want to show as much variation as I can here, but then these dramatic categories, I want those to have equal footing as well amongst each other. I would say that this color scheme is a little soft for what we're looking at. One suggestion might be to keep these darker and to move it across the color a little more quickly. So for instance, maybe I'll show you a quick way to do that. I can just shift all these colors, copy this color, paste, copy, paste, copy, paste, and then for this very dramatic one here, maybe I make this a little orange even, like that. So now what I've done is I've just stretched my colors a little bit more. Same data breaks, but just different color stretching. If I hit apply, you'll watch it change. Boom, and it's just popping out those urban areas just a little bit more. So that's the name of the game with the cartography, is to try to announce the pattern that you're trying to show, but don't distort it. And that's a really difficult balance to strike. But that's the whole game. And I would make these semi-transparent so you can see what's going on below. Maybe a little bit more than that. Maybe we can get away with multiply is just a nice effect you can use so that you can see what's underneath. So sometimes we use a multiply to see the data. Also, like I suggested before, with these tracks, I think you can get rid of the boundaries. So to get rid of the boundaries, you go to symbol, and then under symbol, you can go to the line and get rid of the line. I know I'm going really fast, but this is all kind of probably more advanced than you would need to do for your paper, but just to get the ball rolling, just kind of showing you what's possible. So anyway, this is in the ballpark now of something I would consider an interesting map. It very clearly shows, I could rename my layer here. I could rename this. This is projected incarceration outcomes. Projected incarceration rates. So now if I show that, and I wanted to show my zones on top, I'm not really sure what the narrative is here. It might be a good case for me to also show my commercial areas. I think I showed you guys how to do that last time. So here's the commercial areas with a crosshatch. That's a really interesting thing, being able to show this area, all these places that were ex-commercial in the 1930s and 40s, what do they look like now? Well, very high projections for incarceration rates, right? And I think I showed you guys before, with this symbol, you can kind of do like a hatched thing is a nice way to kind of make it look it's a little harsh, but I think you get the idea. You make it a little thinner maybe. And this is the problem with cartography that we always say, is that nothing's ever done. There's just deadlines, is what a professor used to tell me. So you can fuss with things forever, but if we go back here now, we'll look at our layout. Now we've got another layout for Chester that shows projected incarceration rates. Now we need to change my legend and the title and things like that, but it's kind of a nice supplementary map to my previous map that I'd made. So I hope that's helpful. Good luck, and if you get to the end of this one, good for you. And if you get stuck, come visit me in office hours. Well, the most importantly, we need to get together to talk about your final papers, which may or may not use incarceration rate. Maybe you'll use a different metric, but this is here if you need it. So thank you.